Hi everyone. I'm just going to present really quickly. Can everyone see my screen? Mr.
Yes.
Gihan, can you see it?
Yes, we can.
Okay, great. Okay, so good evening. Thank you to everyone who showed up and came to listen and learn a little more about astronomy and what it is, why is it so important, why is it so interesting, and why is it that Botswana's youth should be more involved in it? So this presentation was actually prepared by the Marapula and Lekhaya Astronomy and Space Clubs, which the Astronomical Society of Botswana started so that we can try to spread more interest about astronomy in Botswana, and that's starting with schools, that's starting with people who are young, and getting them to go the extra mile and outside of their syllabus to actually learn more about something that they might have been curious about when they were younger. Because everyone, a lot of the time, looks up at the sky and wonders, wow, maybe I want to be an astronaut, or what is up there, because it's very, very beautiful. So I'm gonna hand over the start of our presentation to my colleague from Lehigh, Malia. Malia, would you like to introduce yourself and start? Yes.
Yes, good evening, everyone. My name is Maulia. As she's mentioned, I go to Lekha Academy here, and I aspire to be an astrophysicist in the future. So, Zara, do I take over the presentation?
Yes, you can start.
Okay. So, I will first be reading out what we have on our slides, and then I will add on a few points and maybe elaborate a little bit. What is astronomy? Astronomy is the study of everything in the universe beyond Earth's atmosphere. That includes objects we can see with our naked eye, like the sun, the moon, the planets, and the stars. It also includes objects we can only see with telescopes or other instruments, like faraway galaxies and tiny particles. This field of study is regarded as the oldest branch of science. At first, ancient civilizations would interpret the skies in a religious manner rather than a scientific one. This is now known as astrology. Some of the earliest records of astronomical observation dates back to 1600 BC, when the Babylonians tracked the position of celestial bodies and frequency of certain phenomena such as days and nights. So everything we know of astronomy started with ancient civilizations just looking up into the sky, like Zara had mentioned, and wondering what are these lights that we can see? And they decided to name them stars. And they were quite intrigued by them because as humans, our nature is to question. We're very curious. So they looked up and they started questioning. And although to some it seemed very obvious that that's the sky, those are the stars, they give us light. To some, they had more questions. And like we see in this presentation, it was interpreted in a religious manner. They made up a bunch of stories about these stars having to do with how they're aligned, and they came up with shapes that they can see with how they were placed in the sky. And now we can dig deeper into these interpretations and come up with a bunch of scientific theories and all the like. And as we can see, it just started off with what we could see with our naked eye. And later on, as we wanted more answers, we wanted to see these up close. We came up with telescopes where we could actually observe what was up there. And yeah, these are the roots of one of the oldest branches of science. that has now become one of the most widely enjoyed subject. Okay. In the early days of human history, people gazed up at the night sky in awe, creating myths and stories to explain the mysterious patterns and movements they observed among the stars. These ancient stargazers laid the groundwork for what would eventually become the sophisticated science of astronomy. Yes. And next we have the creation of the first telescope. The invention of the telescope in the early 17th century marked a revolutionary advancement in astronomy. In, six, in 1608, Hans Lippershey, I'm sorry if I mispronounced that, a Dutch eyeglass maker, is often credited with creating the first practical telescope. This early instrument, known as a refracting telescope, used a convex objective lens and a concave eyepiece to magnify distant objects. Shortly after, in 1609, Galilei improved upon Lippershey's design and built his own telescope, made from simple materials like wood and metal. Galileo's telescope had a magnification of about times 20, which allowed him to make groundbreaking astronomical observations. Galileo's use of the telescope led to several major discoveries, including the moons of Jupiter, the phases of Venus, and detailed observations of the moon's surface. These findings provided strong evidence against the geocentric model of the universe and supported the heliocentric theory proposed by Copernicus. So initially, like I said, we all the observations we had were what we could see without the use of any devices. And that's probably what led to um, this idea that the Earth was the center of the universe or the center of the solar system. And the telescope was really one of the greatest inventions if we go as far back as we can, because that's what led us to see beyond our planet. And um, it helped us with a lot of calculations that they used to predict a bunch of stuff like the asteroids that may be a threat to us and all the like. So if it wasn't for the telescope, we would still be relying on what we could see, and we really can't see much. The 1700s, discovering Uranus and galactic motion. In the 1700s, the discovery of Uranus by William Herschel marked a significant milestone in astronomy. This was the first planet discovered with a telescope, expanding our understanding of the solar system. Herschel's observations also led to the hypothesis that the positions of stars suggested that our solar system was moving through a larger system, which we now know as the Milky Way galaxy. Like I said, we wouldn't have thought about we wouldn't have thought about there being something beyond just the Earth, or even beyond the solar system if it wasn't for this telescope. Then we have the 1800s, asteroids, Neptune, and spectroscopy. The 1800s saw the discovery of the asteroid belt, a region filled with small rocky bodies located between Mars and Jupiter. This finding added complexity to the understanding of our solar system. In 1846, Neptune was discovered, further expanding our knowledge of planetary bodies. During this period, scientists also noticed missing spots within the color spectrum of sunlight. This observation known as spectroscopy, allowed them to identify the presence of specific elements in the Sun and other stars, significantly advancing the field of astrophysics. So, um, despite the humble beginnings of astronomy, we can see that it led to many amazing things, also contributing to discovering more elements. Then we have the 1900s, relativity, the Big Bang, and dark matter. The 20th century was marked by groundbreaking discoveries and theories. Albert Einstein's general theory of relativity, proposed in 1915, revolutionized our understanding of gravity, describing it as the curvature of space-time caused by mass. In the late 1920s, Edwin Hubble's observations led to the theory that the universe is expanding, which formed the basis for the Big Bang theory, proposing that the universe originated from a single point and has been expanding ever since. Further investigations revealed that there were not enough observable mass to account for the gravitational force holding galaxies together. This, this discrepancy led to the concept of dark matter, hypothesized to make up about 90 to 95% of the universe. Dark matter does not emit, absorb, or reflect light, making it invisible and detectable only through its gravitational effect. So, as we can see, it started with observing. Telescopes helped us look at more planets. We discovered the asteroid belt. We established that there's more celestial bodies. There's more clusters, just like the solar system, and it led to coming up with the general theory of relativity, which is a pretty big deal in terms of science, and even dark matter. So this is how the small ideas of astronomy eventually led to us thinking about something like dark matter, which I think is amazing. Zara, you can scroll.
Is it not showing?
No, I still see the same slide. Maybe it's taking some time. It's moving very slowly. But you have scrolled, right?
Yes.
Okay.
Hold on, let me try again.
Okay.
We were seeing space exploration milestones.
Yes, that is the slide, the next slide. Hold
Yeah,
on.
that's what's supposed to.
We were seeing it.
Okay, can you see it now?
Yes, we
Yeah.
can.
Okay,
Yeah, I
great.
see it. Yeah, space exploration milestones. Yeah. Okay. Space exploration milestones. Space exploration took significant leaps in the mid 20th century. In 1962, Mariner 2 became the first spacecraft to fly by Venus, although it did not carry any cameras. In 1965, Mariner 4 successfully captured 22 images of Mars during its flyby, providing humanity's first close-up pictures of another planet. A historic achievement came on July the 21st, 1969, when American astronaut Neil Armstrong became the first person to walk on the moon, stepping out of the Apollo 11 lunar module onto the lunar surface in an area called the Sea of Tranquility. So we started from taking small pictures to taking multiple pictures of what's beyond our reach to actually stepping on the moon. Okay, discoveries of the 1970s and beyond. The 1970s saw the discovery of the first black hole, Cygnus X1, in 1971. Pioneer 10 became the first spacecraft to traverse the asteroid belt and send back images of Jupiter in 1973. Pioneer 11 followed, capturing pictures of Saturn and its rings in 1979. The Hubble Space Telescope and exoplanets. The Hubble Space Telescope, launched in 1990, provided a more accurate measure of the Hubble constant and the rate of the universe's expansion. It also played a crucial role in the discovery of exoplanets, planets orbiting stars outside our solar system. The first such planet, 51 Pegasi b, was confirmed in 1995. Today, more than 5,000 exoplanets are known, each offering new insights into the diversity of planetary systems in our galaxy. And I think this sums up the history of astronomy and what astronomy is. all all from the small observations to these big questions that we're asking now, and all these very important discoveries that we'll come up with, starting with looking into the sky to having actual pictures of the black hole. And there's still a lot more that we're going to be finding and discovering.
Thank you, Malia. Okay, so modern astronomy has far reaching impacts on various fields, including physics, chemistry, and even biology. Techniques developed for astronomical observations have led to advancements in imaging technology, data analysis, the understanding of fundamental forces and particles, and this will be seen as we now discuss why this field is so important. People often underestimate the gravity of actually just simply studying the stars because, like Malia said, it started with us staring up into the sky. And as we asked more and more questions, we continued to develop theories and ideas about the physical world around us. Now, ideas like general relativity and quantum physics have actually sprung up from these observations and have led to significant changes in the fundamentals of physics and therefore how we actually create machines around us and how we innovate new ideas, is especially in the science field. Because as we change our understanding of the universe and the models that we use to actually conceptualize it, we also start to think of different ways or ideas in terms of creating new machinery, or that can be physical or it can also be through computing, and so computer science, etc. um, and this has all happened within a few centuries, in fact, especially the fast change in technology recently between the previous century and this century. A large amount of it is actually due to the study of astronomy and space. So let's actually speak about how it's helped in medicine and other research, which is quite interesting. Astronomy connects and helps with the medical field through imaging. Both fields require producing high resolution images, which involves using X-rays. So in the field of astronomy, we use X-rays to create high resolution images of outer space. And then we also use that same technique now in medicine. So it actually transferred from astronomy to medicine. That's why many people go into this field known as medical physics, if maybe you haven't heard of it before, where medical physics has a lot to do with using physics to create machinery that will help us in terms of biology, in terms of helping people with diseases, or even helping animals with specific diseases. And so that actually stems from physicists, which is something that a lot of people might have not known. For example, the Fourier analysis uses mathematical algorithms to discover clear images in the midst of noisy signals. This is then applied to when we study the universe, allowing astronomers to see a clear picture which would otherwise be disrupted by visual noise, radiation, and other forms of interference. In medicine, the analysis applies to medical imaging to provide the clearest picture possible. So as we transfer this technology into other fields, and then people in those fields start to innovate it more and more, whatever they've discovered actually can transfer back to astronomy and make the equipment, when it's used specifically for astronomical purposes, even better. So this cross coordination is really, really important. Um, One example of how technology originally adapted for spaceflight has benefited health on Earth is the advancement of the ultrasound machine. In the early 2000s, NASA researchers tested novel uses for ultrasound in diagnostics and remote monitoring from space. Their research and testing expanded the use of ultrasound in diagnostics for evaluations that previously required an X-ray or other less mobile equipment. In addition to developing new uses that are now standard at most hospitals, the NASA researchers created training modules to help non experts like astronauts accurately use an ultrasound machine for timely diagnosis in the field. They then adapted the training to be relevant here on Earth, for example, on the spot diagnosis of injuries to athletes and to those traveling to remote locations such as Mount Everest or the Arctic Circle. Next, earlier this year, during a private astronaut mission to the ISS, which is the International Space Station, researchers from the University of California, San Diego, Stanford Stem Cell Institute conducted experiments intended to help develop more effective cancer therapies. During an earlier mission, researchers found that cancer cells regenerate and resist standard therapies much more quickly in space than they do on Earth. This finding inspired researchers to use an accelerated timeline and organoid models to test how cancers like leukemia, colorectal cancer, and breast cancer adapt to resist therapies. In the hopes this understanding will help doctors anticipate cancer mutations on Earth. Cancer is a leading cause of death in the United States and across the world, accounting for hundreds of thousands of deaths each year. The International Space Station National Laboratory is advancing cancer research through studies that cultivate stem cells for possible therapeutic applications, crystallize proteins for improved drug discovery and delivery, and test therapies to find those that work better or have fewer side effects. Other projects seek to improve 3D cell culturing for more accurate drug testing that could reduce the failure rate of current drug discovery efforts. Um, yes. So, what is really interesting to a lot of people, they don't realize that being an astronaut is actually a secondary, it's a secondary occupation, and you have to have a first occupation before becoming an astronaut. You don't necessarily have to be a pilot if you want to be an astronaut, or be in the army if you want to be an astronaut. If you want to be an astronaut, you can also be a biologist or a doctor, and because there's a lot of research that is conducted specifically in space due to the fact that there are different conditions on Earth. So it offers perhaps a different environment for researchers and scientists. And now there are new fields of occupation that are coming in the world, such as become the field of astrobiology, which 10 or 20 years ago did not even exist. And so, as this field of astronomy and space, and therefore everything like physics, expands, it just starts to create more and more jobs for people around the world. Um, this is a picture of an ESA astronaut. His name was Alexander Gerst, not is, he's alive. He's exhaling into an analyzer for this airway monitoring experiment, which actually studies airway inflammation in crew members. This investigation could help keep crews safe on long-term missions to the moon, Mars, and beyond, and improve treatments for patients on Earth with asthma or other airway inflammatory diseases. So it's very interesting how, again, Maudie started with, whoa, we're just looking up and looking at the stars, to now us wanting to actually perhaps one day even move to Mars and set up a system there for living, and be able to utilize the raw materials that are on these other planets, especially as our own Earth gets more and more polluted, or as we're running out of fossil fuels. A lot of scientists are thinking of ways to try and acquire the fuels that are actually available on other planets. And this wouldn't have been possible if we didn't just start with simply creating a telescope to just look up into the sky. Now, of course, our technology is so much more advanced, and we can actually go up there and get the materials and make use of them on Earth. So, astronomy has provided a wealth of tangible, monetary, and technological gains, but perhaps its most important aspect is not one of economic measure. Astronomy continues to revolutionize our thinking on a worldwide scale. Historically, it has been used to measure time, mark the seasons, and navigate the vast oceans as well. As one of the oldest sciences, astronomy is deeply rooted in every single culture's history. It inspires us with beautiful images and promises answers to the big questions, acting as a window into the immense size and complexity of space. This perspective fosters global citizenship and pride in our home planet. It's a way to connect us across the globe, because for the first time in centuries, we now have communication systems where we can actually communicate within seconds with people who are across the globe. And although this is a very like normal idea to me and you, because we've been living with our phones and texting people very easily, 100 years ago, or let's say, yeah, 100 years ago, 200 years ago, this was a very, very like far reached idea for people to be able to communicate to the scale. And that's why collaborating with scientists across the world is so important, because we are bringing all of our different ideas and our different cultures and our different perceptions of the world and how things might work together to actually, increase the pace of how we innovate on a massive scale. And it just shows how astronomy is like a way to really bring people together. One of the most critical contributions of astronomy is its role in studying how to prolong the survival of our species. For instance, understanding the sun's influence on Earth's climate is crucial for predicting changes in weather, water levels, and other environmental factors. The environmental movement, which is a very, very recent movement in actuality, like maybe 100 or so years, now, people speak about CO2 levels, speak about how, the Earth is getting too warm. Global warming is a big phenomenon, but this wouldn't have been possible if we hadn't been able to actually study the influence of the sun on the Earth's climate and come up with theories for what is it that actually causes global warming. And so this again, it just stemmed from astronomy. So only through the study of the sun and other stars can we actually fully grasp these processes. Additionally, mapping the movement of objects in our solar system enables us to predict potential threats to our planet from space, as demonstrated by the meteorite impact in Chelyabinsk in Russia in 2013. So, as we can see, astronomy plays a really, really big role on a massive scale globally and across all disciplines. It has influenced everything because we are looking beyond ourselves at, the wider everything, the wider entire universe. So that is why it's so crucial for our youth to develop some sort of connection with astronomy, even if they don't go and study it at a university level, but to have the critical thinking skills that astronomy provides you with. The questions that you start to ask yourself is really helpful to anyone across all disciplines. Nurturing an interest in astronomy among youth is crucial for inspiring the next generation of innovators. Notice here, I didn't say scientists. It's not just for scientists, but innovators of any kind. People innovate not only in the science field, but also in fields of philosophy or fields of politics. It is important for people to have this critical thinking mindset of asking questions and being able to think about the world in a multifaceted manner. So, innovation is not just limited to scientists. Um, by engaging young minds through educational programs, through workshops, and access to telescopes and astronomical data, we can actually cultivate a passion for astronomy and science at a very young age. And also through clubs like the clubs that we've now started to include in secondary schools. So, one can also notice from the history of astronomy, which we have just discussed, how this field of study has led to great discoveries such as the theory of general relativity and by extension areas of physics such as quantum physics that have actually altered the very fundamentals of our perception of reality. And in fact, even today, we are struggling to make connections between general relativity and quantum physics, which is quantum physics being the more modern or new phenomenon. But it's not that we are disputing it. So we can show that we just keep coming up perhaps with another idea that can actually connect these two fields together. Perhaps the models that we are using to understand or to propagate the idea of general relativity and quantum physics, perhaps there's a bridging model that we are unaware of. And so that will only be able to be understood if we actually ask the correct questions, and definitely by people who are young, because they have such fresh ideas about the world and are not really limited by, I guess I don't want to say older people, but in the sense that a lot of us, even me myself, having gone through some sort of education now, I have a certain ideas about how physics works in a very rigid manner, where the education system has not provided um, an opportunity for a lot of young people to ask questions and to come up with their own models of the world and to ask their own questions about how things actually work. Simple things like, for example, the kinetic theory of matter, which is us thinking that within matter, everything is made up of these small point like structures. That's a model. We don't know if it's true. And that's someone who came up with that idea. And then we did a bunch of experiments and we're like, okay, this works. And so now we've been taught these things in a very rigid manner, that this is how it is. This is, how it should be. And this is everything, like all the experiments that have been done, and they cannot be faulted. But I feel that the education system needs to allow for more um, I don't, for more space where we can come up with our own ideas, and the youth can come up, specifically very young people, ages of 12 young, or under, or even throughout their teenage years come up with their own ideas of how they think the world actually works, make up different models. Today we have a different model other than um, the kinetic theory of matter, which states that matter is made of point-like structures. Now we have string theory, which states that matter is not made up of point-like structures, but rather of these little strings that actually vibrate at different frequencies and therefore cause what they make up to like the different frequencies that they have is what actually causes it to be a different piece of matter. And it's a very new phenomenon, but if we introduce these ideas to people at a young age, although they might not be able to fully grasp every single part of them being introduced to it at such a young age and then having this time to really think about it and you know propagate it forward is really important because of the fact that children are so they have such a big imagination, as stated by Einstein, that he said the famous quote that knowledge is limited, whereas imagination embraces the entire world. It stimulates progress and it gives birth to evolution. So he actually stated that imagination is more important than knowledge. Often we think that knowledge has such a great power, but really it's the power of our mind and imagining how things can work. People coming up with ideas that might seem silly at first and then testing them. And a lot of young people really do have these ideas. So it's so important to get them involved in this. Youth involvement in astronomy also fosters international collaboration and cooperation. Astronomy is a global endeavor with scientists and researchers worldwide working together to unravel the mysteries of the cosmos. Encouraging youth participation in international collaborations and exchange programs promotes a cultural understanding as well. So, just to summarize everything we've spoken about so far, we spoke about how astronomy, which was a very simple idea at first, it just started with us staring up at the sky and being fascinated with the stars, being fascinated with these little objects that are just shining there, and asking questions about them, to us suddenly being able to look millions of light years away backwards in time, because we know that light takes time to travel to Earth, and therefore we are able to actually look into the past, so far as to look at even the beginning of the universe. We have recently gotten a new telescope. I think it was in 2021, if I'm not mistaken. The James Webb Space Telescope, which was recently launched, and now we are able to get even more advanced images of the past, and it's coming up with new ideas. Someone research recently showed that the telescope had some pictures that actually prove that perhaps the Big Bang theory might not be correct because of something to do with the galaxies. Looking back at the picture, the galaxy um, was really big, and it was really already formed at a proper level. When we're looking at the Big Bang, initially the galaxies were being formed. So as we look back in time and look back out into space, um, the galaxies closer to us are meant to be more developed. And then further away from us, when we're looking into the past, they're less developed. But when looking through the James Webb Telescope, we actually discovered that that galaxy, which was closer to the time of the Big Bang, it was already formed too well. So how is that possible for it to have formed so quickly? So even now, we're just innovating on such a massive scale. And these innovations have caused change in many disciplines, in chemistry, in biology, in medicine, in the ideas of philosophers, in the ideas of even linguists and people across every single discipline, people who are writing books. Literature across the world has changed. Science fiction is a phenomenon. It is a as a genre of books, which, and also a genre of films, which is actually relatively new if we compare it to the history of humanity. So it's just astronomy has influenced us in a very massive way, and it's very important for us to get the youth involved, even if it's giving them like a base understanding, but just giving them that opportunity to use their imagination and expand their thinking, and allow them to be curious about the world around them, because it's such an encompassing discipline. But yes, so I will hand it over to Axel now, who is a member of the Marapula Astronomy and Space Club in Upper Six with me. Yes.
Thank you very much, Zara. Good evening, everyone. My name is Axel, and I'm a student at Marapula, as well as a member of the Astronomy Club. So this next part of the presentation focuses around the astronomy in Botswana and how we can advance the field and why it's important. Zara, could you just continue to the next slide?
Yep. Just trying to get there. Sorry. There we go.
Thank you. So the first benefit would be educational benefits. We inspire STEM education. So astronomy captivates students and the public, fostering interest in science, technology, engineering, and maths, this being STEM subjects. And this can lead to an increased enrollment in STEM courses and a stronger scientific workforce. Another benefit would be critical thinking and problem solving. So studying an astronomy will encourage critical thinking, problem solving, and analytical skills, which are valuable across all disciplines and careers. Another major point to bring across would be scientific advancement. So contributing to global knowledge. So by participating in astronomical research, Botswana contributes to the global understanding of the universe. Collaborative projects with international institutions enhance the country's scientific reputation. And technology development astronomy drives technological advancements such as improvements in imaging, data processing, and communication technologies. These innovations often have broader applications beyond astronomy. And cultural significance. So preserving indigenous knowledge. Botswana's indigenous cultures have rich astronomical traditions. Integrating this knowledge with modern astronomy helps to preserve cultural heritage and provides a holistic understanding of the cosmos. And national identity and pride. Achievements in astronomy can foster national pride and a sense of identity. Success in this field showcases Botswana's capabilities on the global stage. And then economic development. So astrotourism, which is a big field that's been popping up lately. Botswana's clear skies and remote locations make it an ideal place for astrotourism, attracting visitors and generating revenue. Locations like the Kalahari Desert and Okavango Delta offer unique stargazing experiences, as well as job creations. The development of astronomy-related infrastructure and initiatives creates jobs in various sectors, including education, tourism, and research, not to mention any further astronomical programs. Then environmental awareness. So promoting dark sky conservation astronomy advocates for reducing light pollution, which benefits the environment and wildlife. Dark sky initiatives help preserve natural nocturnal habitats, which is a big part of the Botswana. And then sustainable practices. The focus on astronomy encourages the implementation of sustainable practices, such as energy efficient lighting, which can have broader environmental benefits. Then international collaboration. So global partnerships engaging in international astronomical projects fosters collaboration and knowledge exchange. Botswana can benefit from shared resources, expertise, and knowledge. Positioning in space science active participation in astronomy positions Botswana as a key player in the global space science community, opening opportunities for further collaborations and advancements in the future. Lastly, educational outreach and public engagement. So raising public interest. Astronomy has a universal appeal and it can engage the public in scientific discourse. Public outreach programs can inspire lifelong learning and curiosity. As well as empowering communities, educational initiatives in astronomy can empower communities by providing access to scientific knowledge and opportunities for local involvement in global projects. So, in summary, astronomy is important in Botswana for its potential to inspire and educate, contribute to scientific and technological advancement, preserve cultural heritage, drive economic development, promote environmental sustainability, and foster international collaboration. So, to focus more on the ventures that we have currently in Botswana, so Botswana is making scientific progress, significant scientific progress in advancing its space-related technology with a focus on collaboration and innovation. One notable innovation is the partnership between the Botswana International University of Science and Technology and the South African Radio Astronomy Observatory to establish a radio telescope in Botswana. This partnership represents a crucial step in enhancing Botswana's capabilities in radio astronomy and space research. By working together, BIUST and SARAO are leveraging their expertise and resources to build and operate the radio telescope, fostering knowledge and exchange in the development of specialized skills in the field. And lastly, another initiative that Botswana has launched is the National Space Program that's recently been set in motion. So this aims to develop its own space program and launch a homegrown nanosatellite within 3 years. The program aims to create a constellation of satellites, starting with a 3U nanosatellite for Earth observation, followed by larger 6U and 12U satellites. The program will be domiciled at the Botswana International University of Science and Technology in collaboration with local, regional, and international partners. The program is driven by President Masisi's vision of a knowledge-based economy and aims to utilize satellite data to improve various industries, including agriculture. The program reflects the growing African space industry with increasing investment and the development of space programs in several countries, including Ethiopia, which has just launched its second satellite. This information is from an article in 2020, but additional information on its developments are not currently available as it seems.
Another one of the collaborations that Botswana has now committed to back in 2014 is actually the Square Kilometer Array project, which is an intergovernmental international radio telescope project that is being built in Australia and South Africa. It is meant to be the two largest radio telescope arrays in the world. So it's going to be in Australia, but then also in South Africa, and therefore also in Botswana as well. The collecting area is actually about 11 million square feet. Botswana confirmed its participation in this project, and it was revealed by the Minister of Infrastructure, Science and Technology, Johnny Swartz, during the International Association of Science and Technology for Development in Africa. So Swartz actually told participants that Botswana would host a subset of the radio telescope dishes as part of a 3,000 strong complement of dishes stretching across southern and east Africa. So we are just going to have a small portion of the dishes in Botswana's land as well, which shows Botswana's commitment in prioritizing and placing science and technology as a major driver of our economy in the upcoming future. So that is what we've done so far and what we could find that Botswana has done so far. It is clearly a field that Botswana is trying to get more and more involved in, and it's specifically great because, as Axel mentioned earlier, Botswana has very, very clear skies and very little light pollution. There are very, very massive areas of land that have not been used by the public yet. So, Please excuse me. And so therefore, there's a lot of room for creating facilities that can actually propel the astronomy and space field in Botswana. Thank you. We hope you enjoyed. That is it from us. Yes.
Thank you very much, Zara and your team. Uh, I'm in awe of this presentation that you and your team put together. Well done indeed. I feel proud to be the moderator of such an event that you organized, starting the inception of astronomy that Maulia clearly explained, and then you went on to show the future of astronomy, and then Axel coming in and showing how Botswana fits into this future. And it's wonderful to know that the youth are going to take astronomy forward, and it's so promising. Thank you so much, Zara and your team. I'm sure there would be questions that you would like to ask Zara and her team. Please do. I'd like to ask Axel a question. I wonder whether you know that the National Astronomical Research Institute in Thailand, the director of that institute, and its leading scientists are coming across to Botswana in the month of August. And there is an opportunity for the Astronomical Society to meet up with this team. Would you and the rest of your team who are presenting here be interested to meet up with this team?
I think most definitely we would really like to jump at the opportunity to speak to people who are actually in the field,
Yes.
to get a good scope of how it is, because a lot of our
Yes.
members, as well as a lot of the Lekhai members, would probably be interested in going further into astronomy, such as
Yes.
astrophysics. And I
Yes.
think getting hands-on experience, or at least hearing from someone who's had hands-on experience, would be a really
Sure.
good way of finding out if that's something they want to do.
Sure. We will arrange that, because Narit, I wonder whether you could go into their website. Thailand is one of the most advanced countries in astronomy, and they are in the last 10 to 15 years they've advanced tremendously. Every single senior secondary school in that country has telescopes in the school. That's how they've reached the grassroots of the Thai people. And I'm sure you and your team would enjoy to meet up with them. We will do that.
Thank you very much. We'd really appreciate the opportunity. Yeah.
Yes, Zara, I wonder whether you know that the ESA is one of the astronauts belonging to ESA is coming into Botswana in the month of October, and
Yes.
there would be a opportunity for you and your team to meet up with him at UB at the University of Botswana, and I wonder whether your team would be interested to make a presentation at the NARIT meeting, as well as the ESA astronaut. Would you be able to compile something for those two events?
Yeah, sure. I think just if we were given specific dates, because in
Yeah.
October a lot of people are writing their exams, like
Yes.
the final exams for A levels or IGCSE. But if we were just given specific dates, we can try to arrange like a mini presentation. But we would
Yes.
love to definitely engage with both
Yes.
Narrett and the astronaut coming from the ESA.
Good.
It seems like there are two questions from uh,
Yes.
Richard and Sengate. I'm not sure. Sengate? I hope I'm not butchering anyone's name. I'm sorry.
Richard, you may ask your question.
Thanks very much. That was a very interesting talk. Firstly, greetings from Cape Town. Can you hear me okay?
Yes, we
Yes.
can hear you.
Yeah, I'd like to make a comment and then ask a question. The
Okay.
comment is, as you get older, Whether you have an open mind or not is entirely up to the individual concerned. The question is, how did you both get interested in astronomy? And you tell me, and then I'll tell you how I got interested.
Okay. How did I get interested in astronomy? Um, I think for me, it was just a thing from childhood. I think it started with me wanting to be an astronaut. And because I really found a fascination with like the stars in general, just looking up into the stars. And then, of course, science fiction movies, science fiction books really propelled that forward, of course. Um, and then as I got more into physics as well, that's actually how I developed a very deeper, like much more deep love for astronomy, because I found how it connects to everything and how it's such a very like deep field of study. Um, but yeah, also just science fiction films like Interstellar, which is really cool. That definitely fueled my interest as well. And then just my own personal studies. But yeah, Axel, would you like to?
Hi. I would say the same for me. I've always really been interested in space since I was at a young age, especially I started with just reading about the solar system, planets, and then as I got older, um, just learning further. And now, especially for the first time now, having the opportunity to be part of a club with like-minded people who want to explore the same concepts, it's filled it even further. Um, and I think just as well as Zara mentioned, having studied physics in school and one of our topics being cosmology and astronomy, it really helps to understand a lot of the topics better, and that kind of just fuels the love for the topic more. Um, and I think as well, just the space being so interesting, being such a vast expanse with so many undiscovered things and so many
Yeah,
theories to explore.
it's very unknown. I think anyone who likes astronomy, it starts with people like being interested in the unknown in some way. But yeah.
Mm.
Yeah, absolutely, absolutely. I can't disagree with you there at all. There's always something new to learn every day. I actually
Yeah.
got interested in astronomy. I've been doing astronomy as a hobby for 65 years now. I
Oh
got
wow.
interested when I was 2.5 years old. I asked my father one day, I was in the UK, what's that bright light on the horizon? And he said to me, crucially, I don't know, but I'll take you to the library on the weekend and we'll find out. Now, I knew what books were that stage because we had a few hundred at home. But he went to the library and I was amazed at the library. There were these tens of thousands of books. And he said to me, this is where the entire store of human knowledge resides. Because, of course,
Mm.
there was no internet in those days. And I said to him, but I can't read. He said, well, if you want to read, you'll read soon. So by the age of 5 years old, I was reading for meaning because I was really interested and I really wanted to.
Wow. That's such a brilliant story. Wow. Thank you for sharing that.
A
Dr.
pleasure. Just make
Sengazi, would you have something to ask?
Hi, Sarah. Thank you and your team for that interesting talk. Mine is not a question; it's just a comment. And like Jihan said, we have visitors. Okay, I'm Ongs from BIUST. So I'm actually working for AV and SKA Directorate, which is responsible for building the dish that we just talked about. And like there's so many other instruments that are coming to top up on what you said. So we have Harex, which is another interesting instrument from UKZN in South Africa, and the core instrument will be in SKA site where the SKA is. So we are going to host the Audica equipment for them. And we have other small instruments, especially for the HDC. So yeah, there's a lot that is going on this side in the use there. So and yeah, adding on what Jihan just said, we're expecting visitors from Narit, and I'm glad that he mentioned that. And you guys are welcome to join us during that few days of stay. So we're going to have a public talk, which everyone here is invited to. We are going to have a school visit. So they are going to demonstrate how they do their outreach in NARID, because NARID is very good at this outreach program. So you guys are welcome to join us and learn more. And also we are going to have a science week where we just, our department, we are going to just do some astronomy outreach, which is somewhere during August. So you guys are welcome to join us. I think this is a good opportunity for us to collaborate. And I'm glad to see that someone from Lagaye and Maruapula knows about BIUST. Last time we traveled to Mafike University from Lagaye. Is it Lagaye you have, or
Yes, it's
Maruapula?
Lehigh.
Yes,
It's
it's
Lehigh,
like,
yes.
yes.
We're like, okay, hi guys, we are from BIUST. They didn't know about BIUST.
Yeah,
So it's so I'm happy to know that you guys know about us now. So yeah.
definitely. And we should definitely collaborate, because I know that
Yeah.
BIUST has some really good equipment as well, and professors and everything. So yeah.
True that. Okay. Yeah, keep up the good work, and I'm looking forward to talk to you guys and see how we can collaborate.
Yes, definitely.
Thanks.
Thank you.
I have a question of Maulia. Would Maulia tell us how she got interested in astronomy?
Yes, actually, my story is pretty similar to the other two. Um, it started when I was like really, really young. I think I was around 3 years old, maybe. My mom is actually who got me into astronomy. She would tell me about the moon, the sun, how there's she basically said
Yeah.
there's more out there than we can actually that we can
Okay.
actually reach. That's what she used to say.
Okay.
See, you can't touch the sun, you can't touch the moon, and there's more planets around us. And she used to use a candle to explain how the sun was in the center and there was planets orbiting it. I remember this so vividly, but
Okay.
I was only like 3 years old, and that day I told myself I'd be an astronaut when I grew up. But
Wonderful.
later on, I've decided to become an astrophysicist.
Yeah, wonderful. Wonderful. This presentation is being recorded, and I'll put it up on the ASB website. And if any one of you wants it emailed, I could do that as well. Any further questions? Bill, I see your hand up.
Yeah, yeah, Gihan, thanks. Boy, you guys really, I can see, put a lot of time and effort into your presentation. It was really very enjoyable. It made me think. We have a company here in Botswana. We've been working, doing different things with astronomy, stargazing events, and some teacher training and some different stuff. In any case, watching your presentation made me think that, really we should get together and try and share where we can about how we can work together going forward. But thank you very much for a great presentation. And maybe, Gihan, you can share contact details so that we can get in touch
Yes.
sometime in the near future.
Sure, will do.
Perfect.
Thank you, Bill.
Okay.
Yak, you have a
Thank you.
question?
Yes, thank you very much. Just for the students, you talk about exoplanets and talking about black holes. It's far, far away into the universe, which is very excited. But my question is a little bit closer to home. In what extent is your organization involved with solar physics and solar observations? Because that's my field of interest when it comes to astronomy. I'm actually doing solar observations since 1982. And I found a connection between solar activities and climatic behavior, especially over the Africa continent. How far is your organizations involved in solar observations in that context?
Could I answer? Yak, we at the ASP, we are not into solar observation. And what you told me before this presentation and what you're telling me now makes it a very interesting area that I'm sure the students would go into and the members of the ASP would also go into. we should be in touch to get more details of what you are doing in South Africa, in Bloemfontein to be specific.
So
Thank you.
actually, can I ask a
Yes.
question? So the solar observations that you do they have anything to do with the nuclear processes that are involved in the sun, or like is there, I don't know, just asking. Yeah.
Yes, the nuclear processes inside the sun are actually the basic physics for sunspots and sunspot groups. And then from there you get your solar flare activities. And from there you get actually the connections, through the solar wind and interaction with our atmosphere, visible by the auroras. And that sequence is actually coming specifically from the inside of the sun. It starts all with those nuclear processes.
Yeah. Okay, cool.
Bill, do you have a question? Pilane, would you have a question?
Yes, thanks again, everyone. Very nice presentation. I really enjoyed it. The presenters were amazing.
Yeah.
Yes, I have a comment and a question. I don't know where to start, but one little comment before I forget that I came up with right now is about the auroras and how all of that, the magnetic changes affect climate change here on Earth, and what can we do if we believe such things are the ones that are maybe possibly causing climate change, and maybe more than we are doing as people here on Earth. Another one is just a shout out to Dr. Zipam, his former student. He used to teach me physics at UB. I didn't go on to do physics. I changed. I went to BIUST. I did engineering. I just completed, but I didn't fall out of love with physics and astronomy. Uh, Actually, we started at lab that focuses on astronomy and space exploration. We are fascinated with the stars, looking up like that. So I don't know how we can also be engaged with the clubs here and collaborate, network, and you know. So I was hoping to establish that and contacts. So thank you. That's me.
Thank you very much. We will move forward on this matter. Harold, would you like to make your presentation?
Yeah, but I
by
can just answer that young man that my
Yes.
presentation is going to cover auroras and sunspots and matters of that kind. So we can try and do my presentation if you like.
Yes.
I'm not really hopeful, but we can try.
Yes, please do.
Okay.
It'll be a good follow-up if you can share
Yeah.
it.
Can you see that?
Not yet.
Well, let's leave it then, man.
Okay.
Let's leave it. It's useless.
Okay.
I mean, we had that practice run on Monday, and it doesn't seem to have helped.
We will do another practice run. I'm sure
Yeah.
it will work.
Okay.
Yes. So thank you
right.
very much, everyone who participated in this fantastic presentation. Once more, thank you, Zara and your team, Axel, Maulia. Thank you so much for this wonderful presentation. Good evening, and thanks once again for participating. The committee will have
Thank you,
its
Gihan.
committee meeting
Good
following
night.
this. Good night.
Good night, and thanks for the invitation. Bye.
Thank you.
Good night, everyone.
All right, all right. Hello, Pilad.